Hello students, so now we are going to discuss about the product of two vector quantities. So if we are multiplying two vectors with each other, there are two possibilities. First process give us a scalar quantity as an answer and we call that process as scalar product. The another way to produce is a new vector, means when we product two vectors we get a new vector and that process is called vector product. So now in this video we are going to study about scalar product. Vector product we will cover in the next video. So scalar product also known as dot product. Scalar product also known as dot product, and we write it as a vector dot b vector. That's why we call it as dot product. A vector dot b vector shows that we are multiplying two vectors such that we want to get a scalar product from them. There is no concept of direction in the product of these two vectors. So scalar product of these two vectors is defined as the product of their magnitudes and cosine of angle theta between them. So if we have two vectors, then their dot product a vector dot b vector can be defined as the product of their magnitude, means magnitude of a into magnitude of b, and साथ में हमें मल्टीप्लाई करना है cosine of angle theta, where theta is the angle between these two vectors. We can also write it as ab cos theta. That means magnitude of A into magnitude of B into cosine of angle theta, where theta is the angle between the given two vectors जिनका हम product ले रहे हैं, and this is called scalar product of the two vectors. आंसर में हमारे पास कोई डायरेक्शन नहीं होती है. This is a scalar quantity, and if we represent diagrammatically, then if this is A and the another vector is B vector and the angle between them is theta, then the product of these two vectors is AB cos theta. Now we can interpret this geometrically also. Let's see how we can do that. For geometrical interpretation, let's draw a diagram. Suppose we have a vector, right, A vector, and another one is B vector. I am naming them as OP and OQ. This is B vector and this is A vector. Angle between the two is theta. Now according to the dot product, A vector dot B vector is AB cos theta. If I draw a perpendicular from Q on OP, then I get the projection of this B vector over OP. What I get is projection of B vector over OP, and the value of this projection, means this distance, is B cos theta. Value of it is B cos theta. That means we can write it as A into B cos theta, which means that magnitude of A into magnitude of component of B in the direction of A. B cos theta is the projection of B in the direction of A, or component of B in the direction of A. So we can write it as magnitude of A into magnitude of B in magnitude of component of B. B cos theta is component of B in direction of A, right? So A dot B, the dot product, is the product of magnitude of one vector and the magnitude of component of other vector in the direction of first vector. अब इसको दूसरे तरीके से देखते हैं. Means if we draw the projection of A over B, then what happen? For that we are making the diagram again. This is A vector, or we write it as OP, and this is OQ. Suppose this is B vector. Now we draw a perpendicular from point P to OQ that means B vector, this is A vector. We are drawing a projection or perpendicular to get the projection on OQ. This is Q. Now this angle is theta, so the distance or this projection will be, this component will be A cos theta. Now from the formula of A dot B, again we know that AB cos theta, and we can write it as A cos theta into B. A cos theta into B. Then again ये क्या हो गया? It is magnitude of B and it is multiplied by magnitude of component of A. Not A, it is component of A in direction of B. So again the same thing, magnitude of one vector into magnitude of component of other vector in the direction of first vector. So we can define scalar product as, in general, scalar product is the product of magnitude of one vector and the magnitude of component of other vector in the direction of first vector. This is how we can define a scalar product of two vectors. After the definition of a scalar product, let's see its properties. There are certain properties of a scalar product that we have to know. So the very first property of a scalar product is that these are commutative, means whether we are finding A dot B or we are finding B dot A, we get both answers equal to each other. That means scalar product is commutative. Next property is that scalar product is distributive over addition. That means if we find A dot B plus C, it will be equal to A dot B plus A dot C. That means these are distributive over addition. This is the next property. Third property is that if A vector and B vector are two vectors जिनका हम scalar product ले रहे हैं and these are perpendicular to each other, then their scalar product is 0. So third thing is, for two perpendicular vectors, dot product is 0, and it is very simple that theta is equal to 90 degree if the two vectors are perpendicular. That implies cos 90. We are going to use cos 90 in the product and it will be 0. So AB cos theta, which is equal to A dot B, it will also be 0 because theta is 90 degree. That's why AB cos theta is 0. So for perpendicular vectors, dot product is 0. Next property is that for parallel vectors, we know that for parallel vectors theta is equal to 0 degree. In that case, A dot B is equal to AB cos 0. Cos 0 is 1, that means it is equal to AB. So we can say that for parallel vectors, dot product is equal to the product of the magnitudes of the vectors. That means magnitude of A into magnitude of B. This is for parallel vectors. What if the vectors are anti-parallel to each other? So if the two vectors are anti-parallel, or we can say parallel in opposite direction, if A vector and B vector are parallel in opposite direction, this means that theta is 180 degree, in that case cos 180 is minus 1. So we get A dot B is equal to AB cos 180. Cos 180 is minus 1, so it is minus AB. That means negative magnitude मिलेगा हमें, that is the maximum negative magnitude. This was maximum positive magnitude, while in case of anti-parallel or in opposite direction it was maximum negative magnitude. This is the fifth property. One more thing that we have to note is, if we are going to find a scalar product of a vector with itself, means if we are finding A dot A, in that case these vectors are in same direction, for them theta is going to be 0. In cos 0 is 1, so we get A into A cos 0, that is A square. So for two vectors, for same vectors, if we are finding a scalar product of a vector with itself, in that case its answer will be the square of its magnitude. Next property for scalar product is, the seventh property of a scalar product is that whenever we do scalar product of two similar base vectors, now base vectors means I cap, j cap dot j cap, k cap dot k cap, then in such case the scalar product is unity. And when we do scalar product of two different base vectors like I dot j or j dot k or k dot I, then this scalar product is 0. So when we find scalar product of two same base vectors I dot I, j dot j or k dot k, then for all the three its answer is 1. The reason is that for I dot I, j dot j or k dot k, the magnitudes are 1 and the value of theta is 0 degree because they are in the same direction. So cos 0 is also 1. So for same base vectors scalar product is 1. For different base vectors like I dot j or j dot k or k dot I, this answer will be 0. The reason is कि magnitude यहाँ भी 1 होगा, but now in this case theta is equal to 90 degree and cos 90 is 0. So that's why the answer we get for scalar product will be 0 for different base vectors, and for same base vectors it is 1. Next property of a scalar product is that we can, it's not a property actually, it's the way of finding a scalar product. If we have two vectors like a vector is equal to ax I cap plus ay j cap plus az k cap, means we have vectors in form of their rectangular components, then we can find their scalar product by using the formula A dot B is equal to ax bx plus ay by plus az bz. Now reason for this is, when we multiply these terms ax bx, ay by, az bz, I dot I becomes 1 and we get these values. But when there will be multiplication of I cap term and j cap term or I cap term or k cap term, means of different base vector terms, then theta is 90 degree and in that case the value become 0, those terms become 0. So the final answer we get, it will be ax bx plus ay by plus az bz. This is how we can find the scalar product of two vectors if they are given in their corresponding rectangular component form. Also next thing that we can find is the angle between two vectors using this scalar product thing, as we know that a dot b is equal to magnitude of a into magnitude of b into cos theta. So we can find cos theta if we know the scalar product and individual magnitudes of these vectors. So if we know individual magnitude of these vectors and their scalar product, or we know these vectors in terms of their rectangular components, we can find their angle, the angle between them, as we can write it like ax bx plus ay by plus az bz. upon the magnitude for a vector will be ax square plus ay square plus az square into, for b it is bx square plus by square plus bz square. So we can find the angle by finding cos theta for a vector and b vector. These were all the properties of scalar product. In next video we will be discussing about the vector product of the given two vectors. Till then, stay tuned, keep studying. Thank you.